In this video, I will discuss the usefulness of the electric field. Let's say, for example, that we have a positive charge Q1 right here, and let's say that at this location we have another charge Q2. Now, if we want to calculate the force that Q1 exerts on charge Q2, we need to know the value of the charge Q2. If you are in a situation where Q2 can take different values, for example, let's say Q2 could be 1.6 times 10 to the minus 19 coulombs. And let's say that Q2 could also be 3.2 times 10 to the minus 19 coulombs, or Q2 could take any other value. Then we will need to find the electric force from Q1 on charge Q2 when Q2 could take a number of different values. Now, the expression that we need to do this calculation is Coulomb's law. It gives us the electric force from charge 1 to charge 2, and this includes the constant 1 over 4 pi epsilon naught, the charge Q1, the charge Q2, the distance squared between the two charges, and the unit vector r hat. Now, in our case, where we have a fixed charge Q1 and Q2 can take different values, if we look at the expression over here, we see that the constant remains the same in all of these cases. The charge Q1 is also the same. The distance between the two is fixed, and the unit vector r hat is also the same. The only quantity that changes here is the charge Q2. So to make the calculation of all these forces efficient, we could calculate this quantity, because the constant Q1, the distance, and the unit vector are fixed no matter what the value of Q2 is. So we can do this calculation and find this quantity, and then we can use any value for the charge Q2 that we have to find the electric force from 1 to 2. Now, if we have this vector over here, we can use it to do the calculation for the force no matter what the charge Q2 is. And this is the most efficient way of finding the electric force for all the charges Q2 that we have. Now, this quantity that I have circled right here, this is what we call the electric field. And this is the electric field that charge Q1 creates at the location of charge Q2.